Hey Math 20-1s. Today we're going to look at the law of sines. Let's say you're given a question and you haven't got any right angles in your diagram, such as this one. So step one, let's draw a diagram. I think you have that in your notes. Step two, let's draw a perpendicular from AB up to C. From point D, we'll call that CD. Label that a height, H. I'm going to write some trig equations using that height. Side AC and the side we're given BC. So from 78 degrees, opposite hypotenuse, that's the sine of 78, h over 16. From 15 degrees, we've got the opposite and the hypotenuse, side AC. So the sine of 15 degrees is h over AC. Next thing I want us to do is solve each equation for h. So the first equation, multiply both sides by AC. Second equation, multiply both sides by 16. So we get these two equations, both for h. And if they both equal h, that means they must both equal each other. So we can state that. Next step, let's solve for AC. So if I solve for AC, it looks something like this. Or I could have had AC equals the sine of 78 times 16 divided by the sine of 15. All right. Solve that for AC then, and we get the value of 60.5. Very nice. Now that's a lot of work. We had to make right angle triangles in there. We had to solve two equations for different variables. It's got to be an easier way, and yes, there is. We call that method the law of sines. All right. So to use the law of sines, we're going to use that on any oblique triangle. All right, so oblique triangles do not have a right angle in them, as is this example. And so the thing we want to do is use this sine law. And there's two ways to state it. We can have all the sides in the denominator and the angles in the numerator, or we could have all the sides in the numerator and angles in the denominator. Whichever way you want to write it, they're both going to work. I try and make sure my unknown's in the numerator. And notice, as long as I have a complete ratio, sine of A over side A, sine of angle B over side B. If you have any complete ratio, you can use the sine law. So let's try a few examples. So you're given triangle ABC. We know these three things about the triangle. Step one is I'm going to find angle C, because in order to find side C, which we're looking for, I must know the angle opposite it. So if I know two angles in a triangle, I can find the third angle. Some of the angles of a triangle add up to 180. So I know angle C is 60 degrees. I now have a complete ratio. I know angle B, I know side little b, so I can use my sine law written in this form. 10 over the sine of 45 equals C over the sine of 60. So my unknown is a side. I'm going to keep my sides in the numerator. I have one complete ratio, meaning I've got a side and the angle opposite it. That's a complete ratio. As soon as I have a complete ratio, I can use the sine law. Pretty simple equation to solve. I multiply both sides by the sine of 60, and I will figure out side C. Oh, calculator work. We find out that C is equal to 12.25. Second example, I'm asked to find an angle B, or we'll label it angle theta. So again, I've got a complete ratio. I know angle C is 73 degrees. I know side C is 16 centimeters. There's my complete ratio. I know the side opposite angle B, so I can use that to find angle B, or angle theta. So my unknowns in the numerator, I want to keep my angles in the numerator this time. So once we have the equation, we're going to solve for sine theta. Multiply both sides by 12. Sine theta equals this equation, and using our calculators, we figure out angle theta, 45.8 degrees. All right, here's another word problem. Applying the law of sines, we're talking about Stan and Paul observing an airplane. All right, so here's our diagram. Stan sees it angle 51 degrees, Paul sees it from 34 degrees. They're 340 meters apart. And we're going to see how far each person is from the plane and then how high the plane is. So next slide's our solution. All right. So let's redraw our triangle and step one, let's find little side B. So we know the two angles of the triangle. We can find the third angle, 95 degrees, using the sum of the angles of a triangle. I want to find out the side B, which is how far Paul is. So I've got a complete ratio, 95 degrees. Side opposite, that's 340 meters. I can find side B using 51 degrees. Use my sine law. B over the sine of 51 is going to equal 340 over the sine of 95. My unknowns in the numerator, multiply both sides by the sine of 51. I know little side B using my calculator. So we now know how far Paul is from the plane. I want to find little side C, how far Stan is from the plane. Again, I've got my complete ratio. Angle A is 95 degrees, the side opposite, that's 340 meters. So I can make my equation using the sine law. Little side C over the sine of 34 should equal 340 over the sine of 95. Again, solve for C and use our calculators. We find out that Stan is 190.85 meters away from the airplane. Third part of the question was how high is the airplane? So we're going to have to draw a perpendicular to find the height. So a 90-degree altitude. So I'm looking for length AD, which is the height of this triangle, which would be how high the plane is off the ground. So I could use either right angle triangle now from 34 degrees, opposite and hypotenuse, or from 51, opposite and hypotenuse. Doesn't matter which one we use, but it's simple right angle trigonometry now. So the sine of 51 would be the height AD over side C, which we just found, 190.85. So solving for that height, quick calculation. AD would be 190.85 times sine of 51. So the plane is approximately 148.32 meters high. Well done. Last thing we're going to look at today is finding the area of a triangle. So if you're asked to find the area of a triangle ABC as such, let's recall a few things. We can find angle B using the sum of the angles of a triangle. We can use that to find side AC or little b and call that the base of our triangle. So I know a complete ratio, angle C, side C. I'm looking for little side B. I know angle B. So 22 over the sine of 24 equals B over the sine of 88. I can solve for little side B. And we know the base of this triangle now, using a little bit of calculations work, 54.06 centimeters. Now recall, to find the area of a triangle, we need to know the height, or the altitude. So that always meets the base at 90 degrees. I can draw that in my triangle. I can solve for A from 68 degrees. I know that altitude is opposite. I know the hypotenuse is 22, so using a simple trig ratio of sine, we get this equation and we solve it for the altitude. So I now know the altitude is 20.40 and the base of the triangle is 54.06. So I can use the area formula for a triangle. Plug into this formula. Altitude is 20.40, base is 54.06, and we divide that by 2. And we find the area of this triangle to be 551.32 square centimeters. Well done. Here's your assignment. We can work on that next day in class. And this ambiguous case example, we will do this in class tomorrow, so make sure you bring this slide with you, and we'll work on that one at the start of class tomorrow. All right, talk to you guys then.